afternoon, good evening, depending on where you are in the world right now. So today I wanted to talk about agentic AI security considerations. Thank you so much to the previous presenter for talking about ethical and responsible AI, and also to Suzanne for defining agentic AI for us. So this is kind of a continuation of the other presentations we've seen, and we'll talk about agentic AI security. So first, I wanted to introduce myself. So I'm Anmol. I work in cybersecurity. I was a security researcher looking at AI security emerging technologies, and now I'm a security product manager at a leading telecommunications company at Nokia. Just as a disclaimer, this talk represents my own personal views, and I'm giving this talk on my personal time. So this does not reflect the opinions of any organizations or previous employers. So I am also an adjunct professor. I taught AI and machine learning, and I hold a doctorate in cybersecurity analytics. Feel free to scan the QR code for my LinkedIn. I'll also put my LinkedIn in the chat later on. And I also host a podcast called AI Security Update. So I aim to release an episode every Saturday or so where we talk about the latest challenges or news in AI and in cybersecurity. So that's a little bit about me. And now let's get started with the presentation. So what is agentic AI? Suzanne, thank you so much for that definition you provided. But when I looked up online in the industry, we're still debating on what is the universally agreed definition. So depending on where you look, you might see this term defined differently. For example, in MIT, Professor John Horton says generative AI is creation of text, images, and video, but AI agents go further, acting and making decisions in a way a human might. And Google Cloud says agentic AI is a form of AI, which is focused on autonomous decision making. So that means that AI agents, they're making decisions on their own without a human intervention. And IBM also talks about how you could have multiple AI agents to mimic this human decision-making process, and then each agent would perform a specific subtask, and then their efforts would be coordinated through AI orchestration. So basically, all these different definitions exist, but if we just summarize it, agentic AI is a form of artificial intelligence where typically we would think of autonomous decision making. So now this actually poses challenges in the security field because with agentic AI, because it's autonomous, because you have multiple agents, it is more difficult to figure out what exactly the agentic AI is doing. And that can cause security issues like multi-agent exploits, identity and access control exploitation, meaning that the AI agent gets access to something it shouldn't get access to, memory poisoning. And this is because typically with AI agents, we see this risk of minimal human oversight. I was talking to someone the other day, and he said, let me just use an AI agent to order my DoorDash for me. And he said, what if I do that and instead of getting food, it just gives me 12 pounds of lettuce or kale, and I don't actually get my meal. So you can use AI agents and they're really great, but then there are also security considerations with this as well. So because there's minimal human oversight in some cases, that can cause security issues later on. And we're seeing this in the real world. There are many different attacks happening. And this is not to scare you, but that's just the nature of technology is as the technology evolves, we see more and more different use cases and more different ways this technology is being used, and sometimes it's being used to cause harm. This is Jade Puffer is a recent attack, and in this Jade Puffer attack, we see that this was something an AI, a large language model, so generative AI, it could create an entire ransomware operation driven end to end. So typically, when we think about people using AI to perform an attack, traditionally you would have to write code and then you would execute it to create this attack. Now with this Jade Puffer attack, no person needs to type code, no person needs to develop anything. It's fully autonomous and it can create this ransomware operation. So Jade Puffer is definitely something in the security industry we've seen as kind of the turning point. We're seeing more and more autonomous AI attacks and AI agent attacks. How this attack worked was it gained initial access to internet-facing Langflow, and then it basically ran a fully automated campaign, and it was adaptive, meaning it changed over time. And so when it was changing itself, it was able to pivot to the intended target. So typically in security, you would enter the network one way, but then you could move across different devices connected to the network to ultimately get the device you're looking for. If you think of, for example, giving a hypothetical example, let's say a company, you're at an office and you have different computers, printers, smart TVs in that network. Someone could compromise a smart TV, for example, and then they could gain access to a company computer, which would give you access to, for example, accounting information. And so that's basically what this Jade Puffer did, was it was able to enter into the network and then pivot to the intended target that it had. And according to researchers, this is from Sysdig, which is a security research company, the Jade Puffer was self-narrating. So when Jade Puffer was doing different things, they actually used natural language reasoning, and they had very detailed notes about what they were doing. So for example, to give you an example, when you type in something into Gemini or ChatGPT or Claude, pick your tool, sometimes it provides you a reasoning of why it's making that decision. But as humans, we wouldn't provide that detailed reasoning or that detailed chain of thought like a LLM might. So these researchers were able to see that, a self-narrating payload. And from that, they said, okay, this is something that an LLM would write. And so now researchers are having this conversation that maybe from that we can determine whether an LLM or an AI agent is doing something that we need to flag for security purposes. If you're interested, this is the link to the full report. Again, if there are any resources that interest you, feel free to just contact me. I can provide these links to you later on. So we know that there are security issues and AI can attack different things, but we also have growing development on the defensive side. So there are various mitigation techniques. A famous foundation or organization is OWASP. And OWASP is composed of industry volunteers, of subject matter experts, and they propose different mitigation techniques for various security considerations like web application vulnerabilities, and in this case, they have something for agentic application security or AI agent security. Typically in security, if you talk to a security person about AI security or AI agents right now, they would always advocate for a human in the loop approach. So what this means is, I mentioned AI agents are autonomous, meaning they don't require human intervention. So in the security field, we often advocate for human in the loop, which means a person is there to tell you, does this make sense with what the AI agent is doing? If it's not making sense or it doesn't look right, then the human would intervene. So think of, like, for example, when you're driving a Tesla car and sometimes it beeps at you and says, take control immediately. That's an example of human in the loop. So in this case, that would be one thing we could do, to have a manual human override. And then OWASP is advocating to log all of these manual human overrides, like take control of the Tesla car. And it's also recommending that we apply constraints or apply guardrails to the AI, so that we ensure that the AI agent doesn't just do things on its own without consulting us. So with AI security, we try to add as many guardrails as we can to prevent bad things from happening, just to put it at a high level explanation. And we want logging because that keeps track of everything that's happening in the system. And we want it to be immutable, meaning no one can change it, so that the AI agent couldn't hypothetically rewrite the log and say, oh, this never happened. We don't want that. So the main key takeaways, as I show you in this purple box, the main key takeaways are, we want to reduce the attack surface as much as we can, make it as secure as we can, have access control, meaning only those that should have access to the system have access to the system, including AI agents, limit what they can access and what they can do in some cases for security, and also having continuous monitoring. So making sure whenever an AI agent does something or something happens in the system or data is pulled, we log this and we know, okay, this happened or that happened. And we want to validate AI inputs and also AI outputs to say, okay, the AI is doing this, or the AI gave me this result. Does it make sense? Because sometimes when you use Gemini, for example, or any AI tool, and you type in something, you ask it a question, sometimes it gives you information that doesn't really make sense. So, for example, I had a friend, we were traveling in Europe, and we were trying to figure out a place to eat dinner. And so what they did was they asked ChatGPT, hey, what's a good place to eat dinner in the city? And ChatGPT came up with a fake restaurant. So they walked all the way to the restaurant, they got there, and then they found out that restaurant does not exist. And that's just an example to give you, this could happen with any AI tool, but sometimes AI can make mistakes. So we want to validate the AI outputs. OWASP also advocates for other mitigations as well. I've provided the link on the slide. I can also provide this later. They have a very detailed report about mitigation techniques they recommend. But another high-level takeaway is we want to authenticate the AI agent. Should they be able to do what they're trying to do, and also have something called a sandbox, so that prevents the AI from actually infecting other systems. Now, recently in security, we've seen that AI agents can break out of this sandbox, but basically the idea is you're trying to prevent things from going wrong, and you're trying to add multiple layers of security to prevent something from going wrong. You also want to monitor the AI agent's supply chain dependencies. So this means any software that the AI agent is using. So for example, when you're coding something in Python and you have import pandas, import matplotlib, import this library, SBOM means software bill of materials, okay? And it basically lists out all of the different software that you're using. So for example, when you have import statements, when you're creating a script, it would keep track of, okay, you have this software from this library or this this type of software, and you want to basically monitor all the different resources that an AI agent might be using, or what dependencies the AI agent is using. So sometimes you might import a library from an open source tool, and that open source tool could be compromised, for example, and then you would want to be able to track, like, okay, this open source tool had an issue, so we know that. And finally, red teaming the AI agent behavior. So red teaming basically means let's try to offensively attack the AI agent to simulate different kinds of attacks. Like, for example, let's pretend a software that the AI agent is using is corrupted or not secure. Then we basically are trying to figure out what will go wrong and build defenses before that can actually happen. So the main thing with these mitigation techniques is we're trying to add security to the AI agent in different ways. We're basically trying to figure out all the different things that could go wrong, and then based on the highest priority of what we need to fix, we fix that, and we try to secure it as much as possible. And again, that detailed report is on the OWASP website, where you can download it. So this is the Google Developers Group meeting, so I have some advice for developers as well, right? So we want to adopt secure coding practices. And when you're working with AI agents, think about what they're doing and what data they're trying to access. Because oftentimes in security, the security issues are because of data compromise or getting data that they shouldn't have access to. So definitely keep track of what data they're accessing and what actions the AI agents are doing. And this could be done with logging, for example. And also, Google Cloud has a very useful resource called Agentic Resource Discovery. They also have a link on their website where they provide a demo video on how you can actually use this as a developer. But basically, this agentic resource discovery shows you that organizations can provide different services related to AI agents, like servers or AI agents, A2A agents, or MCP servers. And then the AI agents you're using as a developer, they can discover different services they need, search for it, or maybe you have a trusted provider like Google and you want to just automatically use anything Google is providing, then you can do that as well. And then the organizations that actually provide these services, they attach a trust metadata for cryptographic verification. So sometimes when you download files, you'll notice that when you click on a file to download, it tells you like this is the hash value, or this is the way you can verify that it is published by the person we are saying that is published by. So the publishers will basically attach proof that it is in fact a service or a provided resource that is by that legitimate organization. And that's something you should just check when you're thinking about what you download, even if it's using your computer or phones. Think about what you're downloading and make sure it's verified. And then the client agent can dynamically load this provided service and then interact with it using its API, and then returns the result to the user. So this is a very interesting resource I found from Google Cloud, and so I'm sharing it for your reference. And this diagram basically summarizes how this agentic resource discovery works. So like I mentioned, you have companies and they're providing services, for example, like company A, company B. They're providing services. The AI agent could read what services are being provided, or you have a registry. A registry would allow you to discover the service, and the AI agent would check, okay, I'm trying to do this. Do you have anything to do that? then it will provide you that service. You can use APIs, MCP, or A2A AI agents. So this agentic resource discovery, it allows providers to publish AI services provided, AI agents to search and to crawl for different resources or services that they want to use. You can verify that the publisher identity is trusted. And then you connect to that provided resource. So I think this is a very useful resource. So the challenge with this field, what's also very exciting, is that technology is moving so fast, not only for AI, but also for security. And you'll see every day there's a new development. So we see this technology is moving very fast, but that's also very exciting, and we can also still secure these new technologies as they arise. Today it's agentic AI, tomorrow it might be something else. However, the fundamental cybersecurity principles still apply. So basically, when you're thinking about security as a developer, think about what could go wrong, how you can prevent that. So in security, we talk about access control, authentication, resource isolation, privilege checks. So should the AI agent have access to my entire computer? Probably not. Maybe there are files I want to secure. And then also proactively monitor and basically check to see what is happening step by step. And enforce something called defense in depth, which means we want multiple layers of security when we're working with AI agents or any technology for that matter. Think about it like when you're trying to protect a bank. In the bank, they have multiple layers of security: the cameras, the bank teller, the different safes, and the safety overrides. So they have a defense in depth strategy. They have multiple mechanisms or multiple ways they can ensure security. So apply this same thought process to AI agents as well. So that concludes my presentation. I don't know if we have time for questions, but feel free to contact me. You can scan the QR code for my LinkedIn, or you can also contact me via email. Thank you so much.
Biggest thanks. So